Okay, so we're going to start 3.3, which is all about dividing polynomials. And so let me start, instead of starting with that, let's just do some numerical division. It'll give the idea of what we're going to do with polynomials. So let's just say we take 7 and we're going to divide it by 3, which is just 7 divided, so 7 over 3. Well, that's 2 and a third, which is 2 plus 1/3. And so let me just write that down like that. 7 divided by 3 is 2 plus 1 over 3. Or if we multiply both sides by 3, we get 3 times 2 plus 1. So 7 is equal to 3 times 2 plus 1, where this was our dividend. This was our divisor. This is what's called a quotient. And this is the remainder. You're dividing 7 by 3 to get a quotient of 2 and a remainder of 1. Or the other way, where you have 7 divided by 3 is equal to 2 plus 1 divided by 3. So here, this is the dividend. And then the divisor, this is our divisor, which occurs here and here. This 2 is our quotient, and the remainder is this 1 sitting upstairs right here. So these are two forms of what is called the division algorithm. And what we're going to do is we're going to state an analogous division algorithm. So we're going to state an analogous division algorithm for polynomials. So note here, by the way, this remainder here, which is, so the remainder, we'll call it r, is equal to 1. This r must be less than the divisor. The divisor, we'll call this d. So let's call 7, if we called 7p, and our divisor 3 was d, and our quotient q was 2, and our r is 1, we have p is equal to d times q plus r, where r is less than the divisor. Right, the remainder must be less than the divisor. So that's kind of the story for numerics, and we do a similar story for polynomials. So let p of x, d of x be given, where we consider p of x divided by d of x, just like we were considering 7 divided by 3. Then there exist polynomials q of x and r of x, where the following holds true. We have p of x is equal to d of x times q of x plus r of x, where, again, you can think of it in the same way. Here is our dividend. This is our divisor. This is our quotient. And this is our remainder. And just like So remember in the numeric case, we had this situation where r was less than d. Well, it doesn't make sense really to say a polynomial is less than another polynomial, but what does happen is the degree of r of x is going to be less than the degree of d of x here. Okay, so this is one version, so let's call this version A. Version B is simply if you divide both sides by q of x. So then you would have p of x divided by, by d of x, divided by d of x. This is what we're doing. We're doing the dividend, which is the numerator, divided by the divisor, and that equals the quotient plus the remainder divided by the divisor. So this is version B, and this is analogous to, again, in numerics, 7 equaling 3 times 2 plus 1, or 7 divided by 3 is equal to 2 plus 1/3. This is exactly analogous to these, except we're dealing with polynomials. Okay, so whenever we do problems, we're going to write down the solution in both forms A and B. So let's do an example, and we'll write down the solution in both those forms. So let's say p of x is 4x squared minus 2x plus 1, and d of x, what we're going to divide by, is 2x plus 1. So we're essentially looking at the quotient 4x squared minus 2x plus 1 divided by 2x plus 1. And our method here is going to be what's called long division. So we're going to do this via long division. And it's best to just see this by example. So we'll just dive right in. So we're going to do this where the dividend we place inside of this sort of little box here, and the divisor is going to be placed outside here. And what we're going to do is we're going to take this lead term and see how it can divide into the lead term here. So we're essentially going to take this 4x squared and divide it by 2x, because we're doing overall 4x squared minus 2x plus 1 divided by 2x plus 1. So I do 4x squared divided by 2x. Well, that's just 2x. And so what I do is I say, okay, let's take whatever I got here, which is 2x. Let's put that here. And then what I do is I say, okay, let's take this entire term, 2x plus 1, and multiply by the 2x. So let me do that off to the side here. So I have 2x from here. 2x times 2x plus 1, well, that's 4x squared plus 2x. That's what I'm going to write underneath. Let me get rid of these here. That's what I'm going to write underneath right here. So 4x squared plus 2x. And what I do now is I subtract the top from the bottom. So for example, this 4x squared minus this 4x squared will give me 0. And that should always be the case for the lead, what's called the lead term. And then I have a minus 2x and another minus 2x to give me a minus 4x. And this completes one cycle within the long division process. We're going to now repeat this procedure. We're going to say, okay, my new lead term is negative 4x. What I also am going to do here is I'm going to drop down this term plus 1. So I have overall negative 4x plus 1. The lead term is negative 4x. I'm going to divide that by the lead term right here, which is 2x again. So I say, okay, negative 4x divided by 2x. What do we get? We get negative 2 overall. So here, this negative 2, again, we're going to place, this is what we're going to place up here. So let me use a different color for that, just to indicate that we're going to place it. So here we're going to place this right here. And once we do that, we're going to again multiply. So we're going to take this 2x plus 1, which is our divisor, and we're going to multiply it by negative 2. And let me do that off to the side here. So I have negative 2 times 2x plus 1. That's negative 4x minus 2. And I place that underneath our new lead term here. So negative 4x minus 2. I subtract the top from the bottom. And again, the lead term will always disappear here to give you, because you have negative 4x plus 4x, which is 0. And then I have 1 plus 2, which is positive 3. And now notice that the term that I got here, the 3, this 3, so 3 has degree, as a polynomial, it's degree 0, because 3 is the same as 3x to the 0. So this has degree 0. And that degree is smaller. This is going to be what's called our remainder, by the way. This is going to be r of x. Notice that the degree of our divisor, 2x plus 1, the degree of this is 1. It's a degree 1 polynomial. We have gone now to a place where the term we have is smaller degree than what we have in our divisor. And so you can't divide 3 by 2x plus 1 or 3 by 2x. So we stop here. And what we say now is whatever we got here, this part, that's our quotient. And this part here, what we left at the bottom, that's our remainder. So let's write this down now in both forms A and B. So we had p of x being 4x squared minus 2x plus 1. We had our divisor be just 2x plus 1. Our quotient then was 2x minus 2. Q of x is 2x minus 2, and our remainder is just a constant polynomial of 3. So when I write this overall, remember the method A was writing p of x is equal to d of x times q of x plus r of x. So what does this mean? This means 4x squared minus 2x plus 1 is equal to 2x plus 1 times 2x minus 2 plus the remainder of 3, where the degree of r of x was smaller than the degree of d of x, the divisor. That's method A of writing the solution. Method B was to write it out this way, which is just as good. So let's just write that down. So 4x squared minus 2x plus 1 divided by our divisor of 2x plus 1 is equal to the quotient 2x minus 2 plus the remainder 3 divided by 2x plus 1. So you could write, depending on what is asked for, both of these are equivalent, and both of these are the correct solution. Okay, so that's one example. Let's just do one more example, and then I'll leave you here with an exercise to try. And here we'll do just a little bit, something a little bit more elaborate. So p of x, new problem here. P of x now is 5x to the 5th minus 15x to the 4th plus 2x squared minus 4x plus 1, and d of x is x squared minus 3x. Okay, so we have a little bit more going on here. So let's do our long division. We're going to divide p of x by d of x. So We're going to put the dividend here inside this little box, and we're going to put d of x right here. And we're going to first divide this lead term by this lead term. And I'm going to do this now kind of in my head, where 5x to the fifth divided by x squared, that's 5x cubed. Okay, because we're dividing this term, 5x to the fifth, by x squared. So once we have that, well, now we multiply this thing by that and place that underneath right here. So this term would also be 5x to the fifth, and then minus 15. Just turned out that these are both the same. Oh, how interesting. Okay. So this becomes 0 because you have 5x to the fifth minus 5x to the fifth. And this becomes 0, minus 15x to the fourth plus 15x to the fourth, because this distributes. So you get 0. So what you can do now is drop down the next two terms. So we get plus 2x squared minus 4x. And so the new lead term is 2x squared. So when I divide 2x squared by x squared, we get plus 2. So plus 2 here. What does that give me? That gives me 2x squared, because again, we're going to multiply this by 2 to get 2x squared minus 6x. Oops, let me switch back to color. Minus 6x. And then we subtract these. The 2x squared minus the 2x squared goes to 0. Negative 4x plus 6x gives me plus 2x. And there was this 1 that was sort of hanging out, which I can drop down all the way here. And you say, well, notice what's going on here. This term right here, this is a degree 1 polynomial. Our divisor was a degree 2 polynomial, so we've now descended to a place where the degree is smaller. This is smaller degree. So this actually is the remainder. This is the remainder. And this piece right here, this is our quotient. Okay. So how do we write this down? Well, in version A, it's p of x, 5x to the fifth minus 15x to the fourth plus 2x squared minus 4x plus 1. That's equal to d of x, which is x squared minus 3x, times q of x, which is our quotient, 5x cubed plus 2, plus the remainder, plus 2x plus 1. Okay, that's version A. Or you can write it with the division going on, where you divide both sides from A by d of x. So you divide by the x squared minus 3x, and this is equal to 5x cubed plus 2 plus 2x plus 1 divided by x squared minus 3x. So both of these are correct forms of the division algorithm. You can write either one down or both. So let me leave you here with a little exercise. And the exercise is, so suppose p of x is 2x to the fourth minus 6x cubed plus 5x squared plus x plus 2, and d of x is 2x squared plus 1. So you're dividing p of x by d of x, and so you want to find the quotient and the remainder by long division. Okay, we'll stop here for now, and we will start with this exercise next time.